Okay. So my name's Lise Getoor, and I am from the Computer Science Department at UC Santa Cruz, and I do work in machine learning and AI. And I'm going to be talking here, just giving a kind of a tutorial in inferential privacy, so focusing on kind of some of the mathematical and statistical issues, and then at the very end, I'll talk about the policy implications from that. And I'm going to be talking about this particularly in the context where we have networks and how do things change. But let me start with kind of inferential privacy 101. So this is a totally simplistic example where I have a table and I have some individuals and I have some attributes about these individuals. And I may say, okay, one of these attributes, say sexual orientation, I want to say, you know, that's sensitive. And so what do? I say the solution, don't store the sensitive attribute. How many people like this solution? Okay, why don't you like it?
You lose a lot of the richness of the data and your ability to analyze insights can be gained from sensitive information.
Yeah, so even, I mean, that's important. But suppose I'm fine with the fact of losing that information, but the question is just even saying don't store the sensitive attribute. If you look at this data carefully, you see that for the zip code, all of the people in that zip code happen to have the same sexual orientation. So if I just hide this attribute, I actually, because of the ability to do inference, haven't hidden that data. And I think this is a point that I really want to bring home, that importance of understanding the power of inference and the danger of inference. Because I was at a privacy workshop in DC, Privacy and Big Data, about 2 years ago, where people were very much saying, like, oh, if I want privacy, I'll just say the sensitive information, don't store it. You know, that's not a solution without understanding these statistical issues better. And so I really think we need to educate people about inferential privacy. And I mean, this is just in the case of a table. It gets even more interesting and more complex when you have network data. So, you know, online, any kind of network data, but for here, let's think about online social networks. And what are the kind of types of privacy breaches that you can have in networks? I'm going to go through these very quickly. The first two are kind of standard, and you have that with table data too. But then there's some kind of new ones that come up when you have these kind of rich networks. So the first one is identity disclosure. So just the idea is, can you map a record to a particular individual? And a lot of the work in this space has done it using very simple kind of structural properties, so just like degrees and things like that. Obviously, if you have attribute information, you can do this even better. So this is one kind of disclosure. Another is the attribute disclosure. I'm going to go through a little case example about this later, but the idea is, you know, if I have some attribute like political view, how in the context of networks where maybe I do have public profiles and private profiles, this ends up being a richer and harder problem. Then two other kind of different disclosures that are also important once you have graphs are links. So it may be the case that there's certain kinds of links that are very sensitive, and so you want to think about what's involved in making sure that you can't tell that someone participates in a certain kind of relationship. And then the last one that I'll mention is group affiliations. So this also may be the notion that I'm a member of a community, may be some kind of information that I may find sensitive and not want to share. And let me give a little vignette of attribute disclosure in graphs and show how these things all kind of combine together in very interesting ways, and ways that I think it's really important that we understand so that we think about privacy in a more collective way. So I apologize, this is a very dated picture of Facebook. This is from a while ago. But in this case, let's say it's a public profile on Facebook. And I'm going to talk about different kinds of attributes and probably focus on political views. Maybe that's the one that I'm sensitive about. Friendship links and group memberships, and how these all interplay, but how they interplay in the context where I do have some privacy control. So I have some privacy control that allows me to say whether or not I want to make my own attributes public or private, and how does that relate? So the interesting thing is I can maybe control my own attributes, but I can't control the attributes of my friends. And at that time in Facebook, it turned out group affiliations, the control over who released information about who was a member of a group was not the group member, but the group owner. So if I joined a group, I wouldn't have control over whether I would be seen as a member, but the person that owned the group did. And so group affiliation can't be hidden by the user. And so how does that play out? It means that other people's privacy settings are actually affecting your privacy. And so you have to think about that. And the question that we looked at for 4 different online social networks is, how friendship links and group memberships and public profiles, they're turning the lights off, can be used. And this is a place, as a statistician, machine learning person, I would go into like half an hour here on how exactly you do this. But in general, the idea would be you'd have a network where you've observed some attributes and then you have these question marks. I also have these groups, and some of those I have information observed and some I don't. And then the question is, how well can I get back those question marks? And it turns out, probably not surprising to you, that you can easily predict this stuff. One of the things that was actually surprising to us was, everybody knows that you can leak information through friendship links, but it actually turned out that the group memberships were more informative than the friendship links. So they were more homogeneous and you could get more information from them. And so our motivation here was, we need to tell the social network sites to allow finer grained control. And then we also had, maybe it was kind of a naive strategy, but a strategy where, okay, if you want to hide this information, join a bunch of really heterogeneous groups, and that will confuse people. But, I think in a network setting, these notions of who owns the data and then who controls privacy end up getting much more complex. And we really need ways, first off, to educate. So making people aware of kind of how complex these inferential questions are, how then that fits into understanding and managing things. And I don't think that these will necessarily provide the solution, but I think they're incredibly important for informing the discussion around policy for solving these. And then if anybody wants to know about the methods, so more from the machine learning perspective than the policy setting, we have this lecture note synthesis available on privacy and social networks. So thanks.